Okay, problem 2512 reads as follows. You are given 13 meters of thin wire. You form the wire into a circular coil with 50 turns. If this coil is placed with its axis parallel to a 0.12 Tesla magnetic field, what is the flux through the coil? Okay, so first of all, we have a 13-meter long piece of wire, and we're going to coil it into 50 turns. Therefore, one of the features we want to know about this coil is what is the area of each of the turns. The flux going through that coil is ultimately going to depend on the area of the coil, therefore the area of each individual turn, and the magnetic field strength that goes through that coil. And therefore we want the area of the coil, and we're given the magnetic field strength so that we can calculate the flux. The circumference of each turn is going to be the length allotted to that turn, 1 out of 50, which means that the circumference of each turn is going to be 1/50th of 13 meters, or about 0.26 meters, 26 centimeters. It's then easy to calculate the area, which is pi r squared. The relation between the radius and the circumference is such that since circumference equals 2 pi r, therefore r is equal to c, or circumference, divided by 2 pi. So pi r squared, given what we have, then comes out to 5.38 times 10 to the minus 3 square meters per turn. Okay, so let's find the flux through that turn. The flux is going to be equal to the area, which we just calculated, times the magnetic field strength B, times the cosine of the angle between the two being the axis of the coil and the magnetic field. We're told that those two are parallel to one another, so we have the cosine of 0 degrees, or 1. So the flux, therefore, is going to be equal to, and this is the flux for one turn, the flux is going to be equal to the area of that turn times the magnetic field, which goes through it, and that gives us 0.005379 square meters times 0.12 Tesla, and that comes out to 6.5 times 10 to the minus 4 Tesla meters squared, and that's the unit for magnetic flux. So we have about 6.5 times 10 to the minus 4 Tesla meters of flux. Okay, so each turn of that 50-turn coil has the same magnetic flux. So the magnetic flux through the entire coil will be 50 times this, or, as you can see, about 0.032 Tesla meters squared. This, therefore, is the total magnetic flux through the entire coil.